Let's return to the Did You Feel It app for a moment. When we last left off, we observed that the app was crashing on launch because of a network on main thread exception.
Yeah, Android doesn't allow developers to do network requests on the main thread because this will make our apps unresponsive and laggy.
By throwing an exception that causes our apps to crash, this forces developers to follow best practices and run networking code on the background thread, and then return the results to the UI thread.
Yeah, so know that creating threads, coordinating work between them, and communicating the results back and forth is one of the hardest problems in computer science.
In our case, we really don't need the full power of threading. All we want to do is run a single task, which is our HTTP request, on a separate thread from the one that's handling events on our UI thread.
Yeah, so Android framework engineers anticipated that this will be a common need and created a specific Java class that makes this exact pattern really easy. It's called Async task.
Async is short for asynchronous, which means that things can happen at different times. For example, the video you're watching right now is an example of an asynchronous learning. You don't have to be at a lecture hall at a particular time to watch it.
Async task is great for spawning a short-lived one-off task without the overhead of managing a standard Java thread.
It is not perfect for every threading situation, however. If you run into a situation where you need threads that exist for more than a few seconds, you'll need to use something more robust.
Yeah, so be sure to check out the Android Performance Patterns video series on threading linked below for more information.
Anyway, since we don't want the UI for our app to freeze up for a couple of seconds while the app retrieves some data from the internet, Async task is a perfect fit for this part of our app.
Let's look at this in more detail. Async task provides a way for us to easily hand off work to a background thread and then receive the result whenever it's done so we can update the UI. Note that only a small amount of time will be taken up on the main thread to actually get the result and update the UI. So after the work is completed, we no longer need the background thread anymore.